For this video, we're going to talk about the addition rule for probability. First, we need to talk about what a compound event is. These are events that are formed by combining two or more events. So when we're talking about compound events, we're talking about when we have the probability of A or B happening at the same time. And so we're talking about two events that occur at the same time. One way to look at compound events is a contingency table. This is a table showing the distribution of one variable in rows, or one possible event in rows, and the other in columns. It's used to study the association between these events or variables. So let's look at an example using a contingency table. So here we're looking at speeding tickets. The following data represent the number of speeding tickets issued to individuals the past year and the gender of the individuals. So we have females and males, and here we have that 0 tickets were issued, 1 ticket, 2 tickets, and 3 tickets. Anytime that you're working with contingency tables, if it's not already there, the first thing that you need to do is total up every row and every column and get your grand total. So this is the total number of people that were looked at in this survey. So the first thing we want to do is determine the probability that a randomly selected driver is female. So when we're looking at female, we're looking right here, and we have a total of 115 females. So the probability of being female is the total number of females, which is 115, over the total number of people surveyed, which is 197. We divide that out, and we get that the probability of a randomly selected driver as female is 0.584. Okay. So then I want to look at the next one, part B. Determine the probability that a randomly selected driver has been issued 1 ticket in the past year. So now we're looking at 1 ticket in the past year. So the probability of 1 ticket is equal to the total number of 1 ticket, which is 21, out of the total number, which is 197. So the probability that randomly selected driver has been issued 1 ticket in the past year is going to be equal to 0.107. Now the last one asks to determine the probability that a randomly selected driver is female and has been issued 1 ticket in the past year. So this one's a little bit different because we're wanting to look at that that they are female and that they have been given 1 ticket in the past year. That means that we want to look at where both events have happened. So we're looking at the probability of female and 1 ticket. So when you're looking at a contingency table and you're looking for an and, that is where they overlap. Okay? So a female that has received 1 ticket in the last year is going to be 14 of them out of a total of 197. And so the probability that a randomly selected driver is female and has been issued 1 ticket in the past year is going to be equal to 0.071. And so if you're just looking for one event to happen, you look at their total. If you want both of them to happen at the same time, and you look at where they intersect when you're looking at contingency tables. let's continue looking at contingency table. Well, let me go back and find the page that I was looking at. Here we go. That's the page I wanted. Okay, so college degrees awarded. So this table below represents the college degrees awarded in a recent academic year by gender. So we have bachelor's, master's, and doctorate degrees, as well as whether they were men or women. And we have the totals for the rows and the columns already. So we choose a degree at random, and we find the probability first that it's a bachelor's degree. So first of all, we choose a bachelor's degree. So probability that it's a bachelor's degree is going to be equal to the total number of bachelors over the total number that we have, which is 1,907,172. We divide that out and get that the probability that a degree chosen at random is a bachelor's is 0.707. Okay. Now we want to look at, is a doctorate degree or awarded to a woman? So now we're looking for a doctorate or a woman. Okay, normally where we're looking for ors, we look at the doctorate degrees. So that is going to be 4,000. So that's all the doctorates, 4,000 or 46,024 over our total, plus the number of women, which is right here, which is 1,098,371 over our total. Now, I want you to notice something as I correct my writing down here. 172. If you'll notice, right here, this 21,000 was counted with the doctorates and with the females. So we've actually counted that twice. Don't really want to count it twice, so I'm going to have to subtract out one of those times that I counted it. So I have to subtract that out, and because those 21,683 people were actually counted twice in this session, and we really don't want to do that. So you have to be careful when you're doing this. If you're looking at two events that are not mutually exclusive, these are not mutually exclusive events because you can be a woman and receive a doctorate degree. So when events are not mutually exclusive, you have to subtract out what we consider their overlap and pay attention to the fact that you've already counted them in the first item, you counted them in the second time, and so you have to take that back out. And so when we solve this, we get that we have 1,122,712 out of the 1,907,172, which is equal to 0.589. Okay. Now part C is asking us for, we want a doctorate degree awarded to a woman. So we're looking at doctorate degrees and a woman. So the and is actually easier to do here. And I'm going to come up here and write it because I want the probability of woman and doctorate. Because that is actually what we just subtracted out down here in this other portion. Okay? So that's going to be equal to our 21,683 out of our 1,907,172, which is equal to 0.011. Now part D is asking what is it probability of it not being a master's degree? Okay, so we want it to not be a master's degree. So the probability of not a master's degree there's a couple of ways we can do this. One way is to add up everything except for the master's degree. So we could take the bachelor's degree plus the doctorate degree. Or if we don't want a master's degree, we can take a 1 minus the probability of it being a master's degree. Okay? Because all of our probabilities have to add up to 1, where we're talking about probabilities of any random sample. Every probability has to add up to 1. And so everything adds up to 1. And so if I take the probability of it being a master's degree, which is going to be 1 out of 512,647, 512,647 out of my total, and I can do that and just go ahead and do that division. And I get that this is 1 minus 0.2688. So 1 minus 0.2688 is equal to 0.7312. So the probability that it's not a master's degree is 0.7312, which would be the exact same thing I got if I were to add up the bachelor's plus the doctorate degree. You can do it either way. Now the reason why I did it this way is because we're going to talk in a moment about something else. But the general rule of addition is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And if you recall on that last question, we had to subtract out where they overlap that and portion because they were not what we consider mutually exclusive, meaning two events that are impossible to occur at the same time, mutually exclusive. Mutually exclusive events are events such as flipping a coin and drawing a card. Well, those are mutually exclusive because they can't happen at the same time. Or, like on the deck of cards, drawing a 3 or an 8. Those things cannot happen at the same time. So those are mutually exclusive. And so we don't have to worry about this subtracting out the overlap because there is no overlap. But it's always good to look for that overlap there. Now the reason why I was talking about doing the 1 minus for it not being a master's degree is because of something called the complement. The complement of an event is the fact that it does not happen. So the fact that it was not a master's degree is its complement. And a complement is denoted by the A with a superscript of a C. And so the rule of thumb for this is the probability of the A complement is equal to 1 minus the probability of that event happening. Just what I did a moment ago with 1 minus the probability of it actually being a master's degree. And again, the reason why is because the probability of the event happening plus the probability of its complement, the event not happening, has to add up to 1, because the probability of all events in a sample must add up to 1. So what I want you to do is I want you to continue working on probabilities, and if you have questions, please let me know.